Hello and welcome to Electrical Engineering for Professionals. Today we'll explore the fundamental principles of electricity that form the basis of modern electrical engineering. Electric charges. Electricity results from the existence and interaction of electric charges. There are two types, positive and negative. The fundamental law states that identical charges repel each other while different charges attract. The electric force between two-point charges is described by Coulomb's law, which relates the force to the product of the charges divided by the square of the distance between them, multiplied by Coulomb's constant. At the atomic level, matter consists of atoms with a nucleus containing positively charged protons and neutral neutrons, surrounded by negatively charged electrons. A neutral atom has equal numbers of protons and electrons. Electric charge is quantized, existing only in integer multiples of the elementary charge, which is approximately 1.6 times 10 to the negative 19th coulombs. Electrons carry negative charge, while protons carry positive charge. Electric potential represents the electric potential energy per unit charge at a given point. The potential difference between 2 points, called voltage, corresponds to the work needed to move a unit charge from one point to another. Voltage is measured in volts, defined as the ratio of energy to charge. 1 volt equals 1 joule per coulomb. This means that a charge of 1 coulomb crossing a potential difference of 1 volt gains or loses 1 joule of energy. For example, a 12-volt battery performs 12 joules of work to move 1 coulomb of charge through a circuit. Conductors and insulators materials can be classified as conductors or insulators, based on how freely they allow charges to flow. In conductors, like metals, atoms share their valence electrons, creating a sea of electrons that can move freely throughout the material. For example, copper atoms each contribute 1 free electron, explaining its excellent conductivity. The crystalline structure of metals facilitates this movement. When voltage is applied, these free electrons move collectively, creating an electric current. In insulators like glass or wood, valence electrons are strongly bound to atoms in stable covalent bonds. For example, in glass, silicon and oxygen atoms share electrons in strong bonds that leave virtually no free electrons to conduct current. The energy gap between the valence band and conduction band is very large, requiring significant energy to free an electron. The resistivity of insulators is generally many orders of magnitude greater than that of good conductors. Semiconductors between conductors and insulators are semiconductors like silicon and germanium, which have an intermediate energy gap. Their conductivity can be significantly modified by temperature, light, or doping with impurities, making them essential for modern electronics. Electromotive force and electric current generators and batteries don't create charges but act as pumps that create potential differences between terminals by providing electric potential energy to charges. This potential difference generates an electric field that causes free electrons to move in a closed circuit, creating an electric current. The electromotive force of a generator corresponds to the work per unit charge it performs. This energy can come from various sources: chemical in batteries, mechanical in dynamos, electromagnetic in photovoltaic cells, or thermal in thermocouples. Electric current and Ohm's law. Electric current is defined as the amount of charge passing through a point in a circuit during a time interval, measured in amperes. A current of 1 ampere corresponds to 1 coulomb of charge passing per second through a section of the circuit. Ohm's law states that the voltage across a conductor is proportional to the current flowing through it, with the constant of proportionality being the resistance, measured in ohms. This resistance depends on the material's resistivity, the conductor's length, and its cross-sectional area. These concepts form the foundation of our understanding of electricity and explain how electrical energy is generated, transported, and used in our modern society. Thanks for watching this video. Feel free to subscribe to Electrical Engineering for Professionals. We're gradually covering all topics in electronics, from hardware design to software, with new videos posted regularly. See you soon!